everyone. Thanks, Jade. Can everyone hear me okay? Okay. So I'm Emily, as Jade said. I came to Meteor to join the real world from academia. I worked on JavaScript cryptography. I worked on making client-side crypto secure and fast. And I'm not working exclusively on security here at Meteor, but I wanted to give this talk to kind of describe the design principles behind Meteor's security model and how they compare to a traditional web app, and also talk about some of the attacks that you should be on the lookout for and how Meteor can help you protect yourself from them. So in this talk, I'm going to start by giving kind of a more general overview of Meteor's security model. And then I'm going to go into two classes of attacks, cross-site scripting and Mongo injections. And for each of those, I'm going to talk about what the basic attack is, what it looks like, how Meteor can help you prevent it, and maybe some trickier variants. So hopefully there'll be a little something interesting for everybody. So first I'm going to talk about what is the Meteor security model, what is the design behind it, and how does that look compared to a traditional web app. So first of all, in a traditional web app, just like in a Meteor app, you have trusted server code that runs in a privileged environment. It can do special things like read and write to the database directly. And then you have client code, and the overall principle is that server code should never trust inputs from the client, because you never know if it's the intended application code running by an honest user in a real web browser, or some malicious user typing malicious JavaScript into their console, or some really bad guy who created a whole special client that has nothing to do with a web browser just for the purpose of sending evil inputs to your application. So in a traditional web app, in a Meteor web app, server code always has to trust the inputs from the client. But there are a few principles that went into Meteor's design that help give it some interesting security properties that are in some ways different than traditional web apps. So one of these is clean data and code separation. So in a Meteor app, you go make one HTTP request, you download all the code for the app in one request, and then everything on the wire after that is data. So as you'll see as I get into attacks, a lot of common attacks just come from data and code confusion. And in a Meteor app, it would be really bizarre to do something like get the contents of a DDP message and just eval it, or just stick it into the DOM as an entire subtree, because we just know that something coming off of a DDP connection is data. It's not meant to be code. So that can help eliminate a lot of the confusion that leads to classic web application vulnerabilities. Another great thing about Meteor is that there is this clean client-server boundary. So what I mean by that is when a client goes to read or write data from the database in a Meteor app, that read or write is going to either go through a publish function or a method or an allow or deny rule. So those are the places where we have to put access control checks. And that's kind of in contrast to a lot of traditional web apps where a client goes to do a read, and that might hit the server in many different places and many different code paths going through the server code, and you have to remember to put your access control checks on all of those paths. Whereas in Meteor, if a client's going to read some data, that's going to hit a publish function, and we know that publish function is where we have to put the access control check. Another great thing about Meteor is this point about stateful connections that have to be explicitly authenticated. So this is really in direct contrast to a traditional web app where you send an HTTP request that logs you in, and then you get a session cookie set in your browser, and then all the requests after that, that cookie is sent along with them, so those requests are authenticated as you. In Meteor, you have a DDP connection where all the real work is done, and that DDP connection, you can authenticate it so that connection has state, which makes it authenticated as you. You don't have to re-authenticate on every message, but if you go open a new connection, that connection isn't authenticated as you unless you explicitly authenticate it. So this means that Meteor apps are completely immune to a whole class of attacks by design, and those attacks are called CSRF. So what this means, if I go visit site A, and site A opens a DDP connection from my browser to site B, that connection isn't going to be authenticated unless I give it a login token or some other credential that allows site A to authenticate that connection for me. So those are some of the design principles that go behind Meteor, Meteor the framework, and provide it with its security model. But there are also some things to keep in mind when you're structuring your Meteor app. And some of these are things we've all heard a lot of times before, but I think they're definitely worth repeating. So one example is, as I said, server code is trusted and client code is not. And so if you have some secrets in your server code, like API credentials, for example, the place to put those is in your server directory in your app or your Meteor settings. But if you put them anywhere else, that's code that's going to get shipped to the client. So those secrets are no longer secret. So, and of course, just keep in mind that even if you wrap that code in an is server check, that's still going to get shipped to the client. So if you have secrets, put them in your server directory. So that's how you separate server code from client code. But you also have to separate server data access from client data access. And you use publish functions to control client reads, and you can use allow and deny rules or methods to control client writes. But just remember that allow and deny rules are the way that you control writes that clients make from the database API on the client, whereas methods are server code, and allow and deny rules aren't applied to those. So methods, you have to remember to do your own access control checks. You can't rely on the allow and deny rules for those. All right, so I'm going to now jump into some attacks, and I'll start with cross-site scripting. And if you haven't seen cross-site scripting before, the one-sentence summary of it is that an application expects to get some string from a user, and instead the application gets code from a malicious user. And that code ends up getting executed in a victim user's browser. So here's an example. We have our attacker, Mallory, who's malicious, and Mallory's entering a comment on this website. And you can see that the comment she puts in here is just a script tag with some JavaScript inside it. And so this script tag, what it does is it takes the values of local storage and sends it to Mallory. Maybe it sends an HTTP request to her server. Now, Mallory has a victim, Alice. And when Alice goes to view the comments that have been submitted here, you see she sees a normal comment, and then she sees Mallory's comment. And her browser just sees Mallory's comment as an opening script tag with some JavaScript inside it and a closing script tag. And the browser has no idea that this is supposed to be a string. So it treats it as a script, and it executes it, and it sends Alice's local storage to Mallory. So this is your basic cross-site scripting attack. Now, Meteor does some things for you to help prevent against cross-site scripting. And specifically, what it does is that when it's rendering a template variable, it automatically HTML encodes these 6 characters. So this would foil that example I just showed, because those script tags, their angle brackets, would be HTML encoded, and the browser wouldn't interpret them as a script tag. However, it turns out there are some places you can put untrusted input where the attacker can still do something bad even though these 6 HTML characters are encoded. So here's an example of a Meteor app with this template, and it has a user profile in it. And this is a profile where Mallory can provide her website and her username. And the question is, what strings could Mallory provide for her profile here that would result in some JavaScript being executed on Alice's browser when Alice goes to see Mallory's profile? And this is not a rhetorical question, so you can answer. I think you lost your chance now. Well, how would she get out of the? She couldn't add an on-click attribute. The suggestion, by the way, was add an on-click handler. But to add an on-click handler, she would somehow have to escape the href attribute that she's inside, and that would require a quote, and those quotes are going to be HTML encoded. Say it again? So the Meteor encoding will just see a string literal. So it'll see the quote in there. Okay, one more try. Ted? Yeah, there you go. Right. Okay. So the answer is you can put a JavaScript URL, and maybe there are other answers, but what happens with this is that when Alice clicks on this link, the JavaScript inside this URL is going to be executed. So this example, Mallory has caused Alice to alert the value of her local storage. That seems bad, it seems dangerous, but how bad is it? Is there anything that Mallory could put in this JavaScript URL that would result in actually sending the local storage to Mallory, given that anything she might want to do, like send an HTTP request, if you write JavaScript to do that, it's going to include some quotes. Those quotes are going to be HTML encoded, and then we're going to get a syntax error. So can anyone think of any JavaScript she could put in here that would do something really bad without having quotes available? OK, that's an idea. That's a DOS. The suggestion was infinite loop. I mean specifically to export, to actually get the secret data out of the browser. Possibly, but the location, you're probably going to need quotes around it. So what you can do here is a number of things, but one of the things you can do is construct a string from ASCII character codes and then just eval it. So if you put untrusted user input inside an href attribute or other places in a URL, you can just construct any JavaScript you want and eval it and just do whatever you want. OK, so that's why URLs are pretty dangerous to put untrusted user input inside. What about CSS? If Mallory gets to set the background color of her profile page with her favorite color, is there anything she could put in there to execute some arbitrary JavaScript? Yes?
Well, she can close the style quote.
Oh, but quotes are, the suggestion was close the style quote, but how do you do that when quotes are HTML encoded? OK, this one's a little bit of a trick, because it's either like you've seen it or you haven't. But
format for images, or can put it at 364 or something?
Yeah, so then you could set, if you put a data URL, you could set an image arbitrarily, but not. It can be bad. It could be bad, but if you want to execute JavaScript specifically, turns out IE, some older versions of IE, Internet Explorer 7 and 8 in some modes, has this awesome CSS extension called Expression, and it's meant to allow you to compute CSS values dynamically. But the upshot of it is that if you let your users put untrusted input inside CSS, then they can exploit users using IE to execute any JavaScript that they want. And actually, it's not just IE. Firefox, some older versions have a CSS extension called Moz binding, which is dangerous in a very similar way. So the moral of the story is that it's really dangerous to put untrusted user input inside URLs in CSS. So what can you do about it? The general approach is, with most security problems, is to whitelist instead of blacklisting. So you may think you would be safe if you just take all instances of the word JavaScript : out of your input and just replace them with empty string. But actually, you could imagine an attacker putting some white space in between the Java and the script there. And that white space would work just fine in many browsers. They would still evaluate the JavaScript URL. So there are a lot of tricky things like that an attacker can do. And you should instead go with a whitelisting approach, where you make sure that the URL starts with HTTP before you display it. Or for in the CSS example, you have a list of safe colors that users are allowed to use, and you check that the string matches one of those. Another newer proposal that you can look into is called content security policy. And this is a great way to protect users in newer browsers. What it is an HTTP header that you send with your application. And the HTTP header specifies a policy for where scripts and other content can come from on your website. So, for example, you can set a content security policy that says no inline JavaScript is allowed to run on my page, no dynamic JavaScript generation like eval, and external scripts are only allowed to come from my website. So that's just an example. And it's a newer mechanism, so it only applies in newer browsers, but it's a really good way to protect users in those browsers. All right, so now I'm going to go into Mongo injections. And in cross-site scripting, we had an application expecting a string and getting code. And Mongo injections are sort of similar in that they're confusion of types. And usually what we see is an application expecting a string or a number or another simple type like that, and instead getting an object. So here's an example where we have a Meteor method, and just to be clear, you should never be writing this code, and we don't write this code. There's an application or a package for accounts, and it does better password storage than this, and it's better. So don't write this code, but it's just an example. It returns a user object given the username and password for that user. And we have our attacker, Mallory, passing the username Alice, but passing as the password an object. And the result is that Mallory is going to get the user with username Alice with the password anything other than foo, because this object is a Mongo selector. And to be clear, it's great that, one of the features of Meteor is that you can pass JavaScript objects on the client as an argument to a Meteor method, and it automatically gets serialized and deserialized for you. So we want you to be able to pass objects. But in this case, the method needs to be sure that the arguments it's getting are strings and not objects, because we don't want Mallory to be able to get Alice's user object unless she has Alice's password. So Meteor provides a really great tool for you to protect against this Mongo injection, and it's called check. It's a package that you can use to check that your values conform to certain types or patterns. So in this example, we just need to check that the username and the password are string before we pass them into our query. And this would fix the attack that we just saw. So check is really versatile and easy to use, and if you haven't seen it before, here are some examples of how you can use it. So you can check that something is a list of strings, for example, or a list of any pattern. You can check that this profile is an object that has a Boolean key named admin, and it has an optional location key. And optional means if the location key is present, then its value is a string. Or you can check that something matches one of many patterns, like age is a string or a number. So I think you can see it's really easy to use, and you should definitely be using it to check all the arguments to your methods and publish functions. In fact, Meteor has another package called audit argument checks, which helps you remember to check all your arguments. So I'm just going to explain this by example. Here we have a similar Meteor method, which just takes a name and inserts the name. And name is supposed to be a string, but you can see that we're calling it with an object. And if we do this, we're going to see that we inserted this weird thing into the database that has the name as an object, even though we intended it to be a string. Now, if we go add the audit argument checks package, and this is just a package like any other, you just have to add it, and then you don't have to make any other changes to your code. Then when we run this same insert again, we're going to see this exception after the method runs. And this exception is telling us, hey, you forgot to check an argument to your insert name method. So this is a great tool to help you remember to check all your arguments to all your methods and publish functions. But I do want to point out that it's not a silver bullet, because it runs after, the exception gets thrown after the method runs, and it's a runtime check. So this is a great thing to use when you have good testing and QA coverage, and you can discover these kinds of bugs during your testing phase. So that was kind of the overview of Mongo injections. I promised you some trickier variants, but I'm actually just going to give a teaser, which is for my lightning talk, which is going to be a little later on. And the lightning talk is going to be the story of our Meteor 0.641 release, which came out last week. And that release was because I found a bug in a Mongo library. And that bug allowed you, or allowed an attacker, to bypass a security check like this one. So it allowed you to insert a document into the database using this method that has an admin key, even though we're explicitly deleting admin keys before inserting documents into the database. So if you want to hear what that's all about, I think my lightning talk is last on the list, so you'll have to stick around for that. So the takeaway of this talk is that Meteor has some really solid design principles that give it a really cool security model that has some great advantages over a traditional web app. But just like in a traditional web app, trusted server code should always validate the untrusted inputs that it gets from the client. And Meteor gives you some good tools to do this, but there are always some attacks that you should watch out for. I put up this website, security-resources.meteor.com. It has some things like links to an XSS prevention cheat sheet and some relevant parts of the Meteor docs. So check it out, and I hope you find it helpful, and thank you. Any questions? Ted?
Is there a recommended way to throttle the method calls?
I don't think we have a good.
Can you repeat the question?
Oh, sorry. The question was if there's a good way to throttle method calls. You mean to prevent someone like brute forcing an account or a DOS or something? I don't think we have a good official solution right now, but I know we have it on our list of things we're thinking about.
Browsers segregate local storage per domain or something?
Per origin. So an origin is a protocol, domain, and something else and port. Thank you. So for example, if you log in on on your website over HTTP, then that login won't carry over to your website over HTTPS because the login token is stored in local storage. Did I repeat that question? The question was how local storage is segregated in the browser, and the answer was by origin.
Yeah, so if you're doing security in your method, right, you're letting it run on the server and then using the stub to run it on the client, is there any additional value to having the allow deny at that point?
No, well, the allow deny rules won't do anything for your server side method. If your stub tries to write to the database, the allow deny rules will apply there. But I don't think that you would commonly have a stub that's trying to write directly to the database. Oh, I'm sorry. The question was, I forget, sorry.
So when you're running your stub, right, it's going to be served on the client side, the mini Mongo, right, so you get the faster response and all that. What I was asking is if you have all your security and it's running both, obviously you're going to run on the server, and your method on the stub that has all your security, is there any additional value to having allow deny?
Right, and I believe the answer is okay. The question was if you have a method with a client-side sub, is there any value to having allow and deny rules? And I believe the answer to that is no. That the server-side method that actually does the write has to do its own access control checks, and the allow and deny rules won't apply there. Yes.
So you mentioned about the authentication, but what about the signing? Is it similar? You don't talk about it.
Sorry, I didn't quite.
Sign the data?
Oh, signing data? There is nothing built into Meteor for you mean like cryptographic signatures?
Yeah, you authenticate the user.
Sign in like what?
Oh, sign in?
Sign in.
Yeah, so there are various accounts packages which let you. Sorry, the question was what Meteor does to help with user sign in. There are various accounts packages that let users sign in via different methods. So one of those is an accounts password package that just lets users create accounts with a normal username and password and sign in that way. There's an accounts UI package that makes it really easy to put a sign up or login form on your site. And there are other packages for using OAuth with various services. So you can have your users log in with Google or with GitHub or various other services like that.
We have time for one more question.
Yes.
Yeah. I was talking to a developer about Meteor. He said, I don't like it because it isn't secure by default. Similarly, I was in a class, and the first thing we did was this app we were trying out was hack it. We changed all the values by augmenting objects, so on and so forth. So are you thinking of including something like the audit package enabled by default so that you can combat the reputation that Meteor has poor security, maybe?
So the question was, what are we doing to counteract the misconception that Meteor has poor security? So I think that I may not be the best person to answer this question, but I think a lot of that reputation comes from the fact that the original Meteor launch didn't have allow and deny rules. So the original Meteor launch was all clients have all access to the database. So that's just a misconception. There's also maybe a little bit of a misconception arising from the fact that insecure and auto-publish are included by default. So those are things that let the clients read and write from the database whatever they want. I think those are great tools for learning Meteor and makes it really fun to play around with and really fast to prototype everything. But Meteor has really cool secure design principles, and maybe the best thing we can do is try to publicize those.
One other thing we've been considering doing for that is as we're working on our deploy environments, such as that we currently have as Meteor Deploy and our future Galaxy work, making it really clear in the interface in Galaxy when you're managing your deployed apps that, hey, like 9 of your apps look like they're ready for prime time, but this one's serving to the public internet and it still has insecure on. What's up with that? And making that more obvious. It's something it's hard to do without a good UI for administrating your apps, but when we have that, we think that'll help a lot. Like a little bar that says, your app is 75% towards production worthy. Try turning on audit argument checks.
And all right. Thank you, Emily.
Thank you.